Hello my dear students, this is the second video of the series Evaluation of Double Integrals. In the previous video I was talking about the evaluation of double integrals when all of the limits of integration were constant numbers. So in this video I'm going to talk about another type of double integral which is written as a to b g1 x to g2 x with the function f of x comma y with respect to y and with respect to x. Basically we want to integrate the function f of variable x and y with respect to y from g1x to g2x. These are basically the values of y. So that is written as y is equals to g1x and this is y is equals to g2x. In the previous example we considered these two limits of integration as constant numbers, but here these are not constant numbers, these are basically the functions of x. So we are considering this as the value of y is equals to some function of x, y is equals to some function of x. We are integrating this function f of x comma y with respect to y. Definitely the result of this first integral would be the function in variable x. Then we will integrate that with respect to x, considering the limits of integration from x is equals to a to x is equals to b. Taking this particular example, for example, we want to integrate the function, let's say x times y with respect to y from, let's say, from 0 to x, and then with respect to x from 0 to 1. Now here you can see that since we are integrating with respect to y, so these values should be the limits of y. So we can simplify this as integration of x y with respect to y from y is equals to 0 to y is equals to x, and then with respect to x from x is equals to 0 to x is equals to 1. Right, now these are not, this one is constant limit of integration, but this one is not. You can still consider this 0 as function of x. You can write y is equals to 0 times x, right? Y is equals to g1x, y is equals to some function of x. So 0 can be considered as function of x, y is equals to some function of x, y is equals to some function of x, integration with respect to y, and then the result of this first integration will be integrated with respect to x, applying these limits of integration from x is equals to 0 to x is equals to 1. So let's evaluate it. The integration of xy with respect to y would be x y square over 2. Taking the limits of integration, y is equals to 0 to y is equals to x, then with respect to x from x is equals to 0 to x is equals to 1. Solving this, applying limits of integration, y is equals to x, so that would be x times x square divided by 2 minus x times 0 square divided by 2. So instead of writing x times 0 square upon 2, we just don't write this term and integrate this function with respect to x from x is equals to 0 to x is equals to 1. Simplifying this can be written as x power 3 over 2 integrate with respect to x from x is equals to 0 to x is equals to 1. The integration of x cube over 2 with respect to x is x power 4 divided by 2 times multiplied by 4 with respect to x. So instead of 2 times 4 we can write as 8, right? And then taking the limits of integration, x is equals to 0 to x is equals to 1. Now applying limits of integration, that would be equals to 1 power 4 divided by 8 minus 0 divided by 0 power 4 divided by 8, so that would be 0. So the answer of this double integration of the function xy from 0 to x with respect to y and then with respect to x from 0 to 1 is equals to 1 upon 8. So this is how we solve this type of integral, where one of the integral limits, integration limits are constant numbers, and other integral limits are the functions of x. One thing which I want to mention here, that you cannot have this type of integral. For example, from x is equals to a to x is equals to b, from y is equals to g1x, y is equals to g2x, function x comma y dx dy. You cannot have this kind of integration, because you are integrating the function with respect to x, but here the limits of integration are of y. So whenever you want to integrate with respect to y, these limits should be the limits of y. So this should be dy first and then with respect to x. Another thing which you cannot have, let's remove this one and write something else instead of this. Okay, one more thing which you cannot have, you cannot have the integration of this type. For example, y is equals to g1x, y is equals to g2x, x is equals to a to x is equals to b of the function f of x y with respect to x with respect to y. Order of this integration is fine, because we have to integrate with respect to x first, and these are the limits of integration, then with respect to y, and these are the limits of integration. So the order of integration has nothing wrong with it, but the main problem is when you integrate this function with respect to x and apply these limits of integration, you will get some function in variable y, because all of these x values will be converted into constant numbers. So only remaining terms would be the terms in variable y. Then you integrate with respect to y and apply these limits of integration, which is basically the function of x. The resultant of this the second integral would be the function of x, which is wrong, because the double integration will always give you the answer as the constant number. It cannot be the function of x or function of y. We will discuss it. We will discuss this argument in details in a separate video, but for the time being, just remember that you cannot see such type of integrals where you have to integrate with respect to constant limit of integration first and then with respect to variable limits of integration. So that is not possible, right? You will always see either all of these limits of integration are constant numbers, or when you are integrated with respect to y first, these y limits of integration are the function variables in x, and then with respect to x, these should be constant limit of integrations, right? So I hope this video will be useful for you. If you have any questions, queries, you may write them into the comment section. I will be trying my best to solve your queries. Thank you very much.